All right, today we are going to do systems of equations. So let's give you an idea of what we're going to be doing. The systems of equations for chapter 10 here consist of 3 parts. Okay, so we have 10.1, which is solving systems by graphing. And then 10.2, which is solving systems using the addition method. Well, I think using substitution. And then 10.3 is again solving systems using the addition method. All right. So right now we're just going to focus on 10.1, solving systems by graphing. Now the idea is that you're going to graph 2 lines, and let's say we have our chart here. So you have your y-axis, your x-axis, and you graph 2 lines. All right. And you want to see where they intersect. So let's say this is 1, 2, 1, 2, 3, 4. So that intersection is at 4, 2. And that's your solution. That's the idea, is we want to see where, if we graph 2 lines, where they intersect. Okay. And that's what we're going to be doing. Now, there is a total of 3 different outcomes you can have when solving systems, and this is one of them. Okay, so one solution, I'll just say first solution, one solution, xy, ordered pair, xy, 4, 2, all right? 2, you can have no solution. Can you think of a way where you can graph 2 lines and they never intersect? Right? That would occur if you have something like this. So what kind of lines do you think they are? And if you said parallel lines, then yeah. Parallel lines have no intersection. They will never intersect. So no solution. And then 3, we have something called infinite solutions. All right. Now, infinite solutions would exist when you graph 2 lines and you end up graphing the same line. And I'm going to show you an example of that. But the idea is, you graph 1 line, all right? And then you go to graph a second line, and it just happens to be the same line. They just basically overlap, and you end up with just 1 line. So this intersects here, 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 here. Basically everywhere the line exists is the intersection. So there's infinite solutions. Usually occurs when you have the same equation. And again, you'll see what I mean when we do the work for this. All right, that's really the notes going to be for this. Most of the time, they're just going to ask you to graph these in a very specific way. So let's just look at what they want us to do. All right, let me clear this. So, number 1 here, they want us, again, there's only 6 questions here. There's not a lot of work for these because this takes so much work for just 1 question to go through. Number one, what they want you to do is they want you to take the standard form, and if you remember standard form, ax plus by equals c, and they want us to convert it to slope-intercept form. Which is y equals mx plus b. That's what they want us to find, is m and x. Two ways to do this. The most obvious way, all right, something's going on with my internet, so give me a second. I need to refresh my computer or restart it even. All right, so one way, let me clear this, is to just take each equation and solve for y. Is basically take both of these and get y by itself. Now this top equation is real easy. The only way to get y by itself is to first subtract x on both sides. That's gone there. Y stays. And since this is an x and that's a 3, they're not like terms. I just write them in order. Negative x minus 3. So the idea is they want the slope, and the y-intercept. All right. Now the other equation, a little more work, but not really too bad. All right. Oh, so let's go ahead and put that first equation in. It was negative x. So negative x. Don't put the 1 in. Just leave it as negative because it may mark it wrong if you put the 1 in. It likes you to not have that 1 there. And negative 3. All right. So negative x and negative 3. Now the second equation, again, we have to move this x over, so minus 6x minus 6x. We get 6y equals negative 6x minus 18. And if you divide everything by 6, you get y equals negative x minus 3. Which you're going to notice is the same equation. This is what I mean by the same equation. When I simplified both these, I got it into slope-intercept form. They're the same equation. So you type in the same equation. Negative x plus a negative 3. And you're going to see it just doesn't include a second line. If I put negative 7, you see a second line there. Since I put negative 3, it graphs it onto the other line. So there are infinite number of solutions. So anytime you put in two equations, you put in both equations and they're the same equation, it's only going to graph one line, which means you have an infinite number of solutions. That's the idea of what we're going to do here, is basically isolate y, get y by itself, get the slope and y-intercept, put it in, and let the graph software do the work for us. All right. Submit answer. Okay, next question. Let's clear this. All right. So kind of right off the bat, it looks like the same equation, but they're not. And it still wants you to solve for y. So let's go ahead and solve for y on both of these. Let's see, we do the top equation, minus 3x minus 3x. So we get 3y equals negative 3x minus 9. If you divide by 3, you get y equals negative x minus 3 again. All right. Negative x, which you already have there, minus 3. All right. So let's solve for that bottom equation. So minus, minus 3x minus 3x. Again, it's gone here. Bring down the 3y equals negative 3x minus 21. And we divide by 3. Y equals negative x minus 6. So y equals negative x minus 6. Let's plug that in. So notice we have the same slope, but that right here is a different number. So looking at these two lines, they're parallel, so there is no solution. All right, so right here, same slope. All right, and different y-intercept. All right, before we had the same slope and the same y-intercept, which means they're the same line and there's infinite number of solutions. Here we have the same slope but different y-intercept, which means they will never intersect. They are parallel. All right, something happened there. Don't know why I got the wrong answer, but it was still actually correct. So we have, maybe it should be, let's do it again, just make sure we're right. So we're gonna add 3 over, add 3, we get 3y equals 3x, sorry, add 3x over, 3x minus 9, divide everything by 3. We get x, I'll put the 1 in there this time, 1x minus 3. All right, the same thing on the bottom. Add 5x over, add 5x, get 5y equals 5x plus 15. This is positive here. 5 by 5. All right, we get 1x plus 3. So, no solution. There we go. Let's clear this. Oh, wrong button, clear that. Now, this question, this is the two-parter question. They just want you to plug it in to both of them and see if you get a true statement. And that's it. So you've done stuff like this. They want you to plug in for x and for y, and that's terrible, sorry. X and y in for here and here, and see if you get true statements. So we have 2 minus 4, so we have 2 in for x, minus 5 times negative 4 equals negative 17. Basically, we keep going until we get a no. If the first one's a no, we can stop and just say the answer is no. But if first one's a yes and the second one's a no, well, then the whole thing's no. If they're both a yes, then it's a yes. They have to both be yeses for it to be a yes, okay? That happens to be 2 minus 20, plus 20 actually, negative make positive, does not equal negative 17. So we can automatically say no here. Again, you plug it in to see if it works. It may plug in on the bottom one, but not the top. It may plug in the top, but not the bottom. But if it doesn't work for both, it is not a solution. So they're going to give us another one. 3, 4. All right. So here we have, again, x and y. So x is 3 minus 5 times 4 equals negative 17. That's going to give you 3 minus 20 equals negative 17, which is true. So we're good here. Top one's good. You have to make sure it works for both, though. All right. So we have 5 times 3 plus 4 times 4 equals 31. 5 times 3 is 15, plus 16 does give you 31. We're good. It works for both, so the answer is yes. Okay, clear this. They want you to do the same thing, solve for y, but it happens to be really easy here. Because all you have to do here is subtract x over. So we can just write that as, well, y is equal to negative x plus 95. And here, when you subtract x over, we get negative y equals negative x plus 15. So we need to divide by negative 1. We get y is equal to x minus 15. So the first one was negative at negative 1x. We'll leave the negative 1 there just to make sure we're okay. And then it was 1 plus a negative 15. Now the goal is to see where it intersects, and it seems to intersect at 5540. Don't forget, it's x then y. All right. And this one, they just want, the last one, they just want you to look at it. So what's the intersection here? Okay, where did the two lines intersect? That is negative 1, 2, 3, and then negative 1, 2, 3, 4. So negative 3, negative 4. They just want you to point out what's the answer. That's nice. And that's it for 10.1. All right, we're just seeing where do they intersect. Now 10.2 and 10.3 are going to do the same thing, but differently. We're going to go with a different approach. Basically, no more graphing, okay? So you don't have to graph the lines, you just have to use kind of a process in order to solve. So we'll get started on 10.2 after you finish up 10.1, and I'll see you in a bit.